Hello everyone, welcome to A plus BI. This channel is all about complex numbers, and in this video, we're going to be solving a very nice equation with complex numbers. This is actually a rational equation, but we're going to turn it into a polynomial and find all the solutions. All right, so let's go ahead and get started. If you're new to complex numbers, go ahead and check out my lecture videos. You can also check out my other channel, which is Cyber Math. I publish Mondays and Fridays, 2 videos per week. It's all about trigonometry, sometimes complex numbers, trigonometry, algebra, and number theory, mainly. Great, so let's go ahead and see how we can solve an equation like this. Now, first of all, notice that there's nothing factorable in the numerator or denominator that will factor easily. So we're going to go ahead and cross multiply. In other words, we're going to multiply both sides by z squared minus 2z plus 2, okay? And that gives us the following: z squared plus 2z plus 2, that cancels out when we multiply, and when you multiply z by that, we get z cubed minus 2z squared plus 2z. 2z or not 2z, I always make that cheap joke. Now, we're going to go ahead and get rid of the 2z because they are the same. We don't need to worry about it. Now, we're going to put everything on the same side, and that'll give us z cubed. I'm going to bring the z squared over and then switch sides, minus 3z squared, and then, of course, that's going to be, since I'm collecting everything on the right-hand side, it'll be a minus 2 equals 0. Great. Now, we did get a cubic equation, didn't we? And can we solve cubic equations? Is there a cubic formula? Definitely, there is a cubic formula, and I use that a lot. Even though I don't write it as a formula, I'll show you how it's done so that you can remember the process. Because if I just give you a formula, you're going to memorize and you'll probably forget it sooner or later. Now, to solve this problem, first of all, we're going to make it depressed, which means we do want this not to have anything squared, like z squared. Of course, we're going to change the variable, so we don't want any quadratic terms. Make sense? And to be able to do that, we're going to set z equal to something like w plus 1. And let me tell you where that 1 comes from. How do you know that? Well, you look at the coefficient of z squared, which is negative 3, and you negate that number and divide by the degree, which is 3. In other words, you take this number and divide by negative 3, which gives you 1, and then you just add that to another variable, and that's going to be your new thing. So now we're going to replace z with w plus 1 everywhere. That's going to give us a really nice cubic equation. You'll be amazed how nice that is. Now let's go ahead and replace z with w plus 1 cubed minus 3 times w plus 1 squared minus 2. If you want, you can also set it equal to 2. No big deal. We're going to have to collect everything at the end anyways. Now, we're going to have to expand this. So it's going to be w cubed plus 3w squared. Since this is well known, I can just do it the normal way. And then minus 3 times w squared plus 2w plus 1. You got to memorize these formulas. And then it's going to equal 2. No big deal. We're going to have to add all the constants at the end. Now, this gives us w cubed plus 3w squared plus 3w plus 1. And then distribute the negative 3. And you'll notice that something cancels out. Okay, great. Now, take a look. W cubed, 3w squared. W squared cancels out. And that was our goal. That's why this is the right way to do it. And if you don't know how to do it, you can say, hey, I want to replace z with w plus h. And then to make w squared 0, what's the h value? And you're going to end up with h equals 1. Make sense? That's the way to find out how this is done if you don't memorize it. But that's easy to memorize, hopefully. Okay, great. Now, what are we going to do? Let's kind of put it together. W cubed, we have 3 minus 6, that's at minus 3w. We have a 1 minus 3, which is a negative 2, and I'll put that on the right-hand side by adding 2 to both sides. This is going to turn into a 4. Great. Well, this is still a cubic equation, so should I just solve it with the cubic formula? Because we haven't used it yet, right? We only made the equation depressed. We depressed this equation. Now, it's in depression, okay? Now, we can use the formula, but it's always worth checking rational root theorem, which means if you put it in the standard form, any number that divides 4 could be a rational solution. And those numbers are usually 1, 2, 4, and they're negatives, right? So you can kind of check it out. 1 is not going to work. 2 is not going to work. We can check it out. 8 minus 6 minus 4, Nope, that's not 0. If you check 4, 4 is going to make w cubed bigger, so it's not going to work either. -1 is not going to work. Well, it looks like it's going to work. For example, if we had something like this, maybe it would work. I don't know. Or something like this. I think 1 would work in this case, right? But we don't have any of those. So, -1 doesn't work either. How about -2? Because I have to test all of them, right? -2 is going to give me -8 plus 6 minus 4. Uh-oh, that doesn't work either. And obviously, -4 is not going to work. So there are no rational solutions. We can safely say that there are no rational solutions. So what are we supposed to do? Use the cubic formula. So I'm going to go ahead and go back to this format, okay? Because what I'm about to write is hopefully going to help you remember how this is done. We're going to use a plus b cubed minus 3ab times a plus b. This is the formula that I normally use for sum of two cubes. But guess what? This gives you the cubic formula. How? If you assume that, okay, a plus b is w, then you do get another cubic equation, one of whose solutions is a plus b, right? So what does that mean? If I can compare this equation to mine and find the values of a and b, then I can find w, right? Or what I'm looking for. So to be able to do that, we're basically going to compare these two equations, which means ab is equal to 1 and a cubed plus b cubed is equal to 4. Awesome. What does that give us? Are there any rational solutions? Probably not. So let's go ahead and solve this system. I'm going to cube both sides here and then replace b cubed with 4 minus a cubed and substitute here, okay? So it's going to give me a cubed times 4 minus a cubed equals 1. And you got to remember, this is not going to be a hexic or a cubic equation. This is going to turn into a quadratic. Why? If you set a cubed equal to c, and there's a good reason because we need b at the end. Now you're going to get c times 4 minus c equals 1, which gives you c squared minus 4c plus 1 equals 0. Easy, right? Now you turn the cubic into a quadratic, which is nice because we know how to solve quadratics. The formula is fairly simple. Now you can use either completing the square, subtract 1 and add 4, or add 3 to both sides, or you can just use the formula. Let's go ahead and use the completing the square method. Add 3 to both sides. You get 4 here and 3 here. Now notice that the left-hand side is a perfect square because we added the right term. And now we can square root both sides. C minus 2 would be plus minus square root of 3. And from here, C would be 2 plus minus root 3. But wait a minute. What is C? C is A or B, right? No, not really, actually. C is A cubed. So this is equal to A cubed or B cubed because there were two roots, remember? So if you set it equal to a cubed, then a would be the cube root of this. In other words, a can be something like cube root of this, and then b can be the other one, or vice versa. But at the end, it doesn't matter. You know why? Because we're looking for a plus b. If you remember, we set w equal to a plus b. So if you want to solve for w, it'll be a plus b, which is the cube root of 2 plus root 3 plus the cube root of 2 minus root 3. How nice, right? A very radical expression. Well, that's what it is. Now, this is irrational and real, obviously, right? It's a real number. Well, are there any other real solutions? We'll find out. So, but that's not the end because we're not looking for w, if you remember. W comes from where? Let's go back, go back, go back. W plus 1 is equal to z. In other words, w is equal to z minus 1. In other words, while z is w plus 1, I guess I'm confusing myself here. So z is going to be this number plus 1, right? And we were looking for z, weren't we? So the answer, at least one of the roots, will be this one. Now, how do you find the other solutions? Well, you can make this a polynomial like a linear one, z minus, let's just call this z sub 0. You can just turn this into z sub 0 and take your polynomial and divide by this. That'll give you a quadratic and then you can solve it. But that's way too complicated. Don't do it because here's the catch. If you are solving a cubic equation and you solved it, let's say z sub 0 is one of the solutions, right? So here's what happens. You can multiply this by cube roots of unity, okay, which are usually w and w squared. But this is not the same w I'm talking about, so sorry about the confusion. I should probably use a different variable like y maybe. But the idea is multiply this by cube roots of unity, except for 1. Of course, you can also multiply by 1, but it's going to give you the same solution. By the way, z sub 0 is this one. And then you'll get the other solutions. What's the cube root of unity? Let's talk about that. E to the power 2 pi ni, as you know, is how 1 is written, right, in the complex world. If you divide or raise both sides to the power 1/3, you get cube roots of unity. For example, if n is equal to 1, then from here you get e to the power 2 pi I divided by 3, which is the same as cosine 2 pi over 3 plus I sine 2 pi over 3. Let me show you one of them, and hopefully you can find the other one, which will give you for n equals 2. Now, if you take this solution, the cube root of 2 plus root 3 plus cube root of 2 minus root 3 plus 1, remember this was the first z solution we found, and multiply by cosine of 2 pi over 3. What is cosine of 2 pi over 3? By the way, let's find it on the unit circle. 2 pi over 3 is basically 120 degrees, so like 90 plus 30. Its cosine is going to be negative in the second quadrant, but it's going to be like this, like cosine 60, which is 1/2. So we're going to get something like 1/2 plus root 3 over 2i. And of course, the other one is going to be the 240, which is going to be here, and it'll have both the sine and cosine as negatives, and you can pretty much do the same thing. But when you multiply them together, you're going to get a beautiful, beautiful complex solution, right? Don't you love that? Go ahead and do it and simplify and share with us in the comment section, because we are nearing the end. Now, I'm going to show you what Wolfram Alpha provides as the solutions, because I also asked Wolfram Alpha, hey, can you solve this equation? Of course it can, because it's a basic cubic. And ta-da-da-da, the real solution agrees with us, but the cubic solution or the complex solutions, they don't look very good, do they? You can go ahead and verify this with the given information. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care. Don't forget to check out Cybermath and aplusbi, and bye-bye.